Um, Good morning, everyone. Thanks for coming to the CloudStack Collab conference in Montreal. So we'll start with the first talk of this collaboration conference. So I have me, myself, and Mike. And so we are going to present the work that we've been doing for a couple of months on enabling efficient and fast snapshots on CloudStack using on XenServer and SolidFire. So a bit of introduction. So my name is Syed. I work at CloudOps as a CloudStack developer. Right now I'm mostly focused on providing storage solutions to Cloud.ca, which is an entity within CloudOps. I've worked prior to on CloudStack on mostly NetScaler/networking side of it, and right now I'm focused on the storage and combining it with hypervisor, and currently we're using XenServer. A bit introduction on CloudOps. So CloudOps is okay. So CloudOps is a company which so we build and manage clouds. That is our core business. We also provide DevOps infrastructure, and we provide managed services. So if you have, let's say, a requirement, we can manage the cloud for you. We also own and operate Cloud.ca, which is a regional cloud in Canada, and we have two regions, one in Montreal and the other one in Toronto. So I'll hand over the mic to Mike.
Well, we actually have a couple mics, so maybe I can give you that one and we can turn it off. All right, so I'm Mike Tutkowski. I'm a software engineer at SolidFire, which is now part of NetApp as of February of this year. So NetApp, SolidFire, I'm going to kind of refer to them as one and the same. I've been on CloudStack for about 3.5 years now. Been doing development mainly in the storage component, touching a bunch of the hypervisor code as well. I've also been on the project management committee for about 2.5 years. So been doing this for a while now. A little intro to SolidFire. If you're not familiar with us, we're based in Boulder, Colorado. We develop a scale-out storage technology. It's built from the ground up to support guaranteed quality of service. So as you create a volume, not only do you specify characteristics like the name, the description, the size, but you can also specify minimum performance guarantees, what we call also a maximum and a burst number of IOPS as well. So it's really targeted toward cloud environments where you have this shared storage infrastructure where you're running multiple workloads that you don't want to interfere with each other. So that's the main goal of the system. It is an all-flash array. It leverages compression, deduplication, and thin provisioning to get to a cost per gigabyte to be on par with traditional SANs. And also, in one of the areas that I'm primarily utilizing from our system is a REST-like API, which is what I use from CloudStack when I do my plugin development. So some of my work is in the area of developing storage plugins for our system. Other parts are modifying areas in CloudStack, such as the storage area, the hypervisor area, which themselves were not really designed with quality of service in mind. So I kind of have sort of a dual role there. Part of it is in the SolidFire plugins, part of it is in CloudStack's general storage and hypervisor code. So, so that's kind of where I'm coming from, and let's kind of get into the feature that Syed and I have been working on. So not really knowing people's experience level with CloudStack, let's just do a quick overview of what a volume snapshot is. It's really pretty straightforward. It's a read-only copy of a virtual disk And in CloudStack, even though we call that a snapshot, it's really stored on secondary storage. So typically a separate storage system, which kind of makes it more of a backup. So even though we use that term snapshot, I would look at it more as a backup. And what it's used for is when you want to create new volumes in CloudStack, or if it was a backup or a snapshot of a root disk, you can use that backup to create new templates in CloudStack. So it's basically to create new volumes and potentially new templates. And it's stored on secondary storage, which is typically a different storage system than your primary storage. So that's kind of a high-level overview of what a volume snapshot is in CloudStack. A little bit on how they're created. So you can either invoke the API ad hoc, or you can actually set this up through the scheduler. When the time comes, CloudStack's logic will go ahead and instruct the hypervisor to take a hypervisor snapshot. So if this is XenServer, which is what we're primarily going to be discussing here, you would normally see a storage repository with a virtual disk in it. When the time came to create a volume snapshot, CloudStack would tell XenServer, all right, so this virtual disk in this storage repository, take a snapshot of that. That'll lead to the creation of a Delta VHD file inside of that storage repository. Then we take the read-only version of that file and we copy it to secondary storage. So really you have like the original VHD. When you take that snapshot, we freeze writes to that. The new writes go to a new VHD, which is basically a delta of the original, and the original is copied to secondary storage. So that's kind of the process there. I guess we'll move on to the next slide. So there's some benefits and costs to this approach. You do have a crash-consistent copy of your virtual disk, which is what you wanted when you initiated that volume snapshot. If you were looking to have that be on a separate storage system, that is typically the way it's implemented here. So you have that as really a backup as opposed to being a snapshot. And we can kind of discuss the differences between snapshots and backups in a bit. But typically I look at a backup as a copy of your data that's stored on a different storage system from the source. And then the third bullet point is just saying, if your secondary storage is cheaper than your primary storage, which it typically is, you may benefit from some cost savings there. The costs are that it can take a substantial amount of time to copy that data from primary storage to secondary storage. Now each time you're taking a delta snapshot, so ideally it's not a ton of new data that's being copied, but you are physically copying that data from one system to another, which takes time. The second bullet point is referring to the fact that not only is there time involved in this, which limits the number of snapshots that you can perform in a given, say, hour or whatever, so your recovery point objective may be longer. You're obviously using up CPU and in memory and network bandwidth on the hypervisor and in the network to perform this kind of a copy. So it's intensive from a resource standpoint as well. Next one. So I get this question from customers a lot, like, is this the only option that we have? What about, so SolidFire, like many other modern storage systems, has the concept of snapshots and clones. Can we use those? Up until CloudStack 4.9, which is not yet released, the answer was that was the only way of doing it. In 4.9, what Syed and I have implemented allows you to make use of these backend snapshots with a hypervisor like XenServer. And Syed will get into the details of why that isn't actually a trivial process. I mean, we do at SolidFire have an API to take a snapshot of a volume. It's very easy to do. The problem comes in making use of that with XenServer at the same time as XenServer is making use of the source data. And again, Syed will get into the details as to why that is tricky and why it takes thought to get around that issue. So now, though, in CloudStack 4.9, which will hopefully be released in a few weeks, we have this new ability, and I'll go through these bolded points on the next slide, but right here I'll just kind of read this. So you can do this with managed storage if the hypervisor in use is XenServer, and if your storage provider provides a plugin for CloudStack to actually take a snapshot or a clone. If that is met, managed storage using XenServer with a plugin from your provider, then you can actually use the backend snapshot or cloning capabilities of your storage provider when you create volume snapshots. So let's move on to, I believe, which is my last. Oh, I actually have one more slide after this, and just kind of explain what these things mean. So managed storage is, I keep on saying it's a new type of storage in CloudStack, but it's really not anymore. I started implementing it about 3.5 years ago when I first began work at SolidFire. I think it was first released in the 4.2 version of CloudStack, which I believe was September of 2013. So it's been out for a couple years now. It's been obviously augmented over the course of years. We've added new use cases to it. But the idea here is to have a single back-end volume per virtual disk. And the reason you would want to do that is to support quality of service. So if your back-end storage provider provides quality of service controls on a volume by volume basis, you would not ideally want to run multiple virtual disks on that same backend volume. You would want each of the virtual disks to have its own backend volume so that each virtual disk can have its own performance guarantees. So this was the first step I took when I started at SolidFire, was to integrate support for quality of service into CloudStack and then consume that with my SolidFire storage plugin. The second bullet point here is that, this is available, this backend snapshot feature is available in 4.9 with XenServer only right now. So there are plans to do this with VMware and other hypervisors, but for 4.9, when we're talking about it here, it's just for XenServer. And then the final point is kind of what I mentioned on the previous slide. Your storage provider has to provide a plugin for CloudStack, which allows it to integrate with what we've done here, to take snapshots so that they can actually store that data on their back-end system instead of using the traditional approach, which is that copy to NFS. All right, so my last slide is just talking about the benefits and costs of this approach, so you can kind of weigh them against the benefits and costs of what we discussed for the traditional approach. So same thing, actually that first bullet point is exactly the same thing. You have a crash consistent copy of your virtual disk, at least a logical copy. The process, though, of taking this snapshot on modern storage systems is typically very fast, probably sub-second. So instead of having to take that hypervisor snapshot and then spend all that time copying it, which could be minutes, or depending on if you haven't taken a snapshot in a long time, could be a lot of data, could take over an hour, this is done very fast. So this translates into a better RPO, recovery point objective. You can take multiple snapshots in a short amount of time. You can restore to any one of them as you need to. The third bullet point there talks about the fact that if your storage system provides a rich metadata layer, such as what SolidFire has, then it may actually be capable of doing a high degree of deduplication of the data. So for the SolidFire system, if you take a snapshot, it's actually only a matter of a small number of bytes overhead for the storage system. Now, as you continue to write data to the original source, and it diverges from the snapshot, you will store additional data. But in the beginning, a snapshot is very fast and very space efficient. So it may actually mitigate you having saved money from moving that data from primary storage to secondary storage. That was actually a benefit on a previous slide. If you have a storage system that actually is capable of taking very efficient snapshots, you may not have to worry about having really stored any extra data on your storage system for all intents and purposes. The cost here is that it's not really a backup, it's a snapshot. It's stored on the same system as your source. So if you lose that primary storage system, you do lose this data as well. The other one is basically saying that kind of the reverse of that third bullet point. If your system cannot deduplicate data or take highly space-efficient snapshots, then it may be more expensive for you than storing that data, a copy of that data, on secondary storage. So a lot of these benefits and costs, when you compare them against each other versus the traditional approach, are dependent upon what the capabilities of your storage system are. So with this, I'm going to switch over to Syed, and he'll go through some of the more technical details around what was involved in making this happen for XenServer. Thanks.
Thanks, Mike. Okay, so I'm going to start with XenServer Snapshot. So this is how traditional snapshots are working right now in CloudStack and XenServer. And why this is a bad idea. So XenServer uses something called a copy on write snapshot. So what that means is when you take a snapshot of your virtual disk, what happens is a layer gets on top of your current disk, and that acts as a copy on write layer. So it's very fast. It's super fast, but it has its costs. So what happens is if you do this layered approach, as you see here, so as you keep increasing the number of snapshots, what happens is a read which has to read some data from this particular disk has to travel all the way down the disk chain. So each element has to be checked, and this is very slow. Also, writes become very slow. So we have observed in our tests, it takes a 30 to 50% degradation in performance when snapshots are happening. And one of our customers actually wanted to have where they have a very high I/O requirements, and they cannot accept this kind of degradation, especially when you're running something like databases and stuff. So ideal scenario would be your snapshots are taken by the backend, in this case SolidFire, in which case if a snapshot is taken by the backend, we didn't observe any kind of degradation. But why can't we use it currently? So for that, you have to understand how XenServer's storage works. So XenServer treats everything, every storage as a storage repository. So every virtual disk goes inside something called a storage repository. So, and if you're talking about iSCSI, XenServer by default uses something called as LVM over iSCSI. So if you see this figure, so this is a whole LUN, and what you have is an LVM inside the LUN, and each VDI resides in a volume group inside the LVM. So, there is something called as a metadata LVM or metadata logical volume, where you have the metadata associated with each VDI, like what's its UUID, whose its parent is, if it's a snapshot or not, things like that. So now this is one SolidFire LUN, and what the challenge is this. So this is in XenServer, this would be a storage repository or an SR, and on the SolidFire this would be a LUN. So prior to 6.5, the limit or the amount of SRs you can create is only 256. So that was one of the hurdles that we had to face. So we upgraded to 6.5. Now 6.5, in their documentation, they say that it's the number of SRs that you can create is close to 2,000, but it's actually not true. So like we created about 600 SRs, and we already reached around 2 or 3 minutes to create new SRs. So as you have more SRs, the next SR time to create increases linearly. So that's that's not something which we want. And the other problem is, so going back to the slide, so if you have a LUN and if you do a clone of this LUN, you are basically cloning everything here. Now, if you see the LVM has its own metadata inside it, and then the VDI has its own metadata, and each of those have UUIDs associated with it. So what happens is, So let's say if I clone a LUN on the SolidFire and I try to attach that back to the XenServer. So the XenServer will refuse to accept that LUN because it says that that LVM already exists, or the LVM with the same UUID already exists on the XenServer, so it will not attach that LUN. So one of the solutions that we came was to resignature, or something we call as the resignature approach. So what we do is we take that LUN, we do we don't technically attach it to the XenServer, but we do an iSCSI login, and what we do is basically change all the metadata on the LUN. So we change the LVM UUIDs, we change the VDI UUIDs, we change the metadata inside this management volume. Everything is resignatured. So what happens is, once you do that resignature, XenServer accepts this as a new SR. So now what happens is I can attach this back to the XenServer, and it works like a new SR. So this is what we have built for CloudStack. So CloudStack now supports something called as resignaturing, which basically enables this functionality. And we've also certified this by Citrix, so people who are using XenServer 6.5 can use this as a supplemental pack inside their hypervisor. But this is not enough. What we ideally want is to remove the whole LVM layer. So what you want is something like this. You have a LUN and you have a single VDI inside it, because this is easier to clone on the backend, or is easier to snapshot. There's no overhead here. So why do we want to do this? So because the storage repository creation, as I said, is very slow. What we want is a very quick storage repository creation. The creation is very slow because there are a couple of things. So there are XenServer problems where in the code they have very slow checks. They used very slow, like the code they used to do checks is very slow, and they have iSCSI bottlenecks. And they also have some LVM bottlenecks. So what we are trying to do is to remove all of that and to do something like this. But there are some problems with this too. So what happens is, if you use something like this without LVM, you lose the functionality to do XenServer snapshots. But since you are using SolidFire or the backend storage to do snapshots, this technically doesn't affect you. You also lose the ability to do storage motion, which is migrating your volume from one storage repository or one LUN to the other. But in this model, it also is not a problem, because what we are doing is having a zone-wide storage. So you will never have to migrate your volumes from one cluster to the other, because you have a zone-wide storage. So all in all, this is a very good approach. So just to give you a graph, so this is the timing graph that we have. So on the x-axis you have time. On the y-axis you have time. On the x-axis is the number of SRs you create, or the number of SRs here directly translate to the number of volumes that you have. So prior to our optimizations, you have the time, which for a standard LVM SR, it took about like 80 seconds to create about 600 SRs. So the 601th SR would have taken somewhere close to 80 seconds. But after all the optimizations, you are looking at something which is less than 15 seconds. So this is very scalable. So you can have thousands of SRs with all of these optimizations. So this is what we are trying to build. So this would be probably in the next version. So yeah, that's all we have. We also have, so Mike had made a beautiful demo. You can visit that YouTube video to watch that. And yeah, that's it from us.
I don't know if anybody has any questions, if we have any time. Yeah.
So we're still working against a limit of 600 kilometers. So that's 600 SRs to the per XenServer, not per line.
Yeah, so in 4.9, because Syed has not yet implemented the kind of like trimmed down approach without LVM, this all works just fine up to around 600 or so SRs in a cluster. You can use more. It's just, as he mentioned, every time you make a new SR, it becomes slower and slower to create that SR. So you might see, like he says, 601st SR, maybe that takes 81 seconds. Maybe that 602nd one takes 85 seconds or something like that. So it's slower because of these bottlenecks in XenServer that Syed was referring to. Now, in, say, version 4.10, if we're able to do this same functionality with optionally having no LVM, that's where what he says applies, that it'll be very linearly scalable. So maybe one SR takes 10 seconds to make, 600 takes maybe, I don't know, 10 or 11 seconds. It might go up slightly, but it's not going to be this more like, I don't want to call it like an exponential increase. It's not an exponential increase in time, but you will see more of a linear progression with his scaled down, no LVM approach, which hopefully will be in version 4.10. We have the LVM approach in 4.9, which should be out in a few weeks.
So the issue there though is XenServer history has been very bad at dealing with large number of SRs.
Correct.
Especially on reboots.
Yes.
You sometimes have a XenServer with a few hundred SRs sitting there, reboots its scanning runs for an hour. So is there anything in this that will get us along, like both stability and reboot time?
So with 6.5, oh sure. The question is that historically XenServers had some issues when you run large numbers of SRs in a given cluster, especially upon rebooting a host. So in 6.5, the XenServer team did some work, performance improvements, increasing the number of SRs that you can reasonably expect to use in a cluster. And I think we briefly just touched on it in one slide. So the number went up from around 256, which was actually a soft limit, to around 2,000. Now what Syed was noticing is that, yeah, maybe you can do 2,000, but by the time you even get to 600, it's very slow to create the next SR. So ideally, not only would Syed's work be in removing LVM to help speed up some of these operations, I believe you were also working on some iSCSI optimizations, because you did notice some very slowness in hosts when they were rebooted. So we're definitely aware of that, and that's on our radar to make sure that we consider that reboots and things like that, because we definitely know what you're talking about there. Yeah.
Thanks. A couple more questions, but I will hand you the mic so that people on the audience can hear. We have a question over there, and then I'll come back to you, if that's all right.
You mentioned something regarding storage motion might not be a problem because we have zone-wide storages, but I don't think we support it in XenServer currently.
Oh,
are you planning to implement it for XenServer?
I guess we should have been more clear on that. So there is some confusion around zone-wide storage and XenServer's support of it. I don't know how it works with all storage providers, but ever since the 4.2 release of CloudStack, the storage plugins that I've developed for SolidFire, or I guess there's two of them. The one that we're talking about in this presentation does support zone-wide primary storage. So what that means is, for example, you can create a data disk, attach it to a VM in one cluster. You can detach that data disk and attach it to a VM in another cluster. That works no problem, and it has for several years on XenServer, ESX, and KVM.
Julia, is it on?
Yeah, it should be on.
Okay. Zone-wide won't work with XenServer because of the way clustering works. It has to be within a resource pool. Now, you have tricks around it, but
Yes.
I want to call that out, that just
Yeah.
by default, zone-wide primary storage doesn't work within XenServer because of the way that it does its resource pooling.
Yeah, and so as Tim mentions, there has always been some confusion around that, but as he also mentioned, we do have some ways around that. Actually, there's a couple providers now that work on at a zone-wide level with XenServer, but as he mentions in general, see, I think what you're talking about too is the traditional approach where you create a single volume and then you run multiple virtual disks on that same SR. And so in this case, what's happening is there's a single volume per virtual disk. So you see a new volume be created on the back end, an SR is put on that, and then a virtual disk is put within that SR, and then that guy is basically done hosting virtual disks. You might see multiple VDIs within the SR if you used hypervisor snapshots, but if you don't, it's a one-to-one mapping between a back-end volume and a virtual disk, and that's kind of how we make this work at the zone-wide level.
So then, Mike, would it be fair to say that for the purposes of traditional iSCSI and whatnot, primary storage in a XenServer environment, it's not a LUN per VDI model, so we're relying on the hypervisor's capabilities, but you've implemented a LUN per VDI model, which allows you to create portable SRs more effectively.
Yes, and kind of what I do too is I'll take the, as you attach a virtual disk to a VM in a given cluster, I know the IQNs of the hosts in that cluster, and I implemented a mechanism within CloudStack to notify storage drivers. There's a grant access method now. It says what virtual disk is being attached to what VM. You can figure out the cluster from that. You can figure out the host IQNs. You can go and update your own access control lists. So that way, the storage system is allowing the XenServer hosts in that one resource pool to access that back-end volume. If you detach it, we will go ahead and remove the connections from the XenServer side. We'll remove those host IQNs from the, in our case, the SolidFire side. If you attach it to a VM in a different cluster, that's different host IQNs. They get added back into our access control lists, but it's the same access control list, but it's different IQNs for the new resource pool. So we have ways of circumventing that zone-wide issue in this model. So.
Okay, we have one last question.
Sorry, yeah.
And then we're gonna move on.
Very simple question. You mentioned VMware is on your radar. Do you have plans for KVM as well?
Yeah, so right now so as far as the feature set here with the snapshots, I'd like to implement support for ESXi next. And it actually should be easier because the work that Syed did with re-signing UUIDs, VMware already has an API to do that. So they've already given thought to the fact that you might want to clone a volume on the back end. In fact, if you do this manually, I've cloned volumes on the back end and tried to add those data stores into vCenter Server. And vSphere client, it actually pops up a dialog and says, hey, it looks like this guy, based on the SCSI ID, is a copy of another one. Maybe you made a copy of it. If you did, do you want to provide like resignaturing for the unique identifiers? I think that's even where I came up with the term resignaturing. So they already have that functionality built in. I just need to make use of it for ESX. And as far as the QoS stuff is concerned, everything that you can do on XenServer with a one-to-one mapping between a virtual disk and a backend volume can be done on ESX. And it can be done on KVM right now for data disks, not yet root disks. So there's a little bit of difference in the functionality, but a lot of the ESX and the XenServer stuff is very similar. Yep. So.
Thanks, guys.